In our eco column, we used garden soil and grass seeds in our terrestrial chamber, garden soil, 2 beetles, a banana peel, and an apple core in our decomposition chamber, and finally a fish and some elodia in our aquatic chamber.
which is our first.
Yeah.
On November 9th, which was our first day of testing, we had reasonable numbers recorded, which made all our chambers in our eco column be clean and healthy today.
In the terrestrial chamber, our temperature was 20 degrees Celsius and our pH was 7.05.
The temperature for the aquatic chamber was 20 degrees Celsius, the pH was 6.5, salinity was 0 ppm, and the dissolved oxygen was 0.9. On November 14th, our temperature of our aquatic chamber went to 19 degrees Celsius, our pH moved down to 6.4, our salinity stayed the same at 0, and our DO went to 0.8 milligrams per liter. As for our terrestrial chamber, it stayed at 20 degrees Celsius, and the pH went down to 6.95. Something significant about November 14th was that it was the first day that we had a new fish. Also on November 14th, it was our first day to measure the levels of nitrogen, phosphorus, and potassium. For nitrogen in our terrestrial chamber, we had 10 pounds per acre. For phosphorus, we had 20 pounds per acre. And for potassium, we had 10 pounds per acre.
In our aquatic chamber, our nitrogen levels were at 20 ppm, our phosphorus at 10 ppm, and our turbidity was at 0.
On November 16th, our salinity and our dissolved oxygen had changed. Our salinity went from 0 to 30 parts per million, and our DO went from 0.9 to 3.8 milligrams per liter.
The salinity moved up from 0 to 30 ppm because of the decaying matter in the decomposition chamber, which was a banana peel. Also, the DO moved up from 0.8 to 3.8 because the elodia was successful in letting out oxygen, which then dissolved throughout the water. The DO went down from 3.8 to 1.6 because the elodia started dying and was therefore unable to give off as much oxygen that could dissolve in the water.
However, the elodia did not die completely, but rather sustained low DO levels of 1.6 to 1.9 milligrams per liter throughout November 20th to December 3rd, which is considered hypoxic, although did not have significant effects on our fish.
Throughout the project, the pH in the aquatic chamber did not change much from 6.5, and in the terrestrial chamber, the pH stayed at around 7.05. Also, for the temperature, it stayed around 21 for the aquatic chamber and around 20 for the terrestrial chamber. These sustained numbers show that both the fish and the plant in the terrestrial chamber were both healthy and alive during this period of time and were thriving.
So some conclusions could be made from the results of our eco column, and the main conclusion would be that because our nitrogen and phosphorus levels stayed fairly consistent for the entirety of the experiment, you conclude that the nitrogen and phosphorus cycles were flowing smoothly. You can also conclude that DO levels, although they were dangerously low at some points that would suggest the fish would be unhealthy, actually had no effect on the fish, which probably helped our ecosystem because if the fish had died, nitrogen levels would have risen and the phosphorus cycle wouldn't be affected, but the eco column would decline in overall health. But thankfully, our NP and K levels remained fairly constant, along with our salinity, which correlates closely with if any organic matter is dying and breaking down, which none of ours did, and that stayed constant as well. So our column was able to effectively self-regulate